Hello everyone, George here, and it's actually the next day. Let's just say I had some other things to do, and it was a little bit more tricky than I expected to get my HTC Vive setup working again after several months. But anyway, let's go ahead and see the results of the fan script that we had put together in the last video. Hit play, and here we are in the world. I'm not going to put all in the headset, I'm just going to hold it in front of me, and let us see. So we can see our fan blades are slowly rotating. Let's go to the speed and adjust that. So let's keep cranking that up because it's way too slow. So it looks like, what do we want this speed to be to make it look like a real fan? So that's 200. Let's just jump to 400. That's 400. Let's jump to 500. That's a pretty good speed. So somewhere between 5 and 600, I'd say. Let's split the difference and do 550. Yeah, I like that. So we'll stop that. Remember that value, put 550 in there, perfect. Save that scene on out, and that's that. So now we've got our spinning fan that works properly. Power level is currently at 100. I don't have my controllers nearby, so I can't quite see everything going on. Yeah, that one's dead. So I can't test all the features just yet. Let me see, what is it? So I can move between cameras from last time still. Uh-oh, looks like they're moving about. Let's check out the power manager. And we did not make the power manager show the current power level in the game. Let's jump back over to the power manager and force an artificial, failure of the system early on by speeding up how quickly things will actually drain objects. Although in reality I can probably do that a lot easier. But let's just go to the power sink and create an artificial one of, let's say, 20 units per second. Hit run. Now this should very rapidly cause power to be lost in our world. And because of that, everything will shut down and we'll lose the game. But what I'm really interested in seeing is if the fan blades actually do start the coroutine and eventually stop down to a velocity of 0. See if I can get one of these controllers on. I think one of them is active, and hopefully that one actually shows all the power information. There's a controller. Unfortunately, it looks like it's the one that doesn't display anything. Okay, and I need to plug the other controller in. Great. Am I ever going to run out of power? All right, let's go to the power manager, open it up, and make it so we can actually see what's going on by putting our charge as a serializable field. So there's a public float getter for charge. I don't think I can use this with a getter. Let's see what happens. I actually don't know. Let's use a serializable field on the getter and see if that works. I'm not seeing anything over here in the actual power manager itself. So I'm going to assume that no, it doesn't work. And that being said, let's just create a bogus field. We're going to just make it float little charge, and we'll just have little charge equal to whatever charge happens to be during our update. And that way we should continually get pulled. We should be able to continually pull within the GUI of Unity what that is, and we'll just remove that value after we see what happens. Alright, there's our power. Power went all the way to nothing, game over, and our fan slows down and stops working. Great, that's all I wanted to test. So coming back over here, let's go ahead and get rid of charge and get rid of this charge as well. Just making sure again that when we hit, bam, game over, and great, now we can start worrying about that red LED. It is just going to be controlled by the material that's on it. So let's go to the material, go to it right here, give it an emission value, maybe something like close to 0.5, somewhere around there in the red range, so that it is bright even when the lights are off. That is, it looks like it has a light source. Then we'll go over to our script and add in the material so we have access to it. Although we do have the button, correct? Let's see, this is power. let's go to fan. Yes, we do have the LED light right there, which means we can grab the material right in here as well. So let's just do private material LED light material. Within our start method, we'll go ahead and grab that. So let's do is equal to our LED light game object dot renderer dot get material, or get component, or excuse me, dot material is what I want. LED light dot get component, what's it, renderer dot material. So we have the material now. So it's going to stay constant until power goes out. So we only need to work with this variable here within power down fan. We're going to want to store the initial value. So we'll do float initial ambient value, and we'll grab the LED light material dot get, what is it, float, and then we're going to want to access the specific value of the shader. Now to do that, we're going to have to jump over here, grab this object here. Let's grab the Selective Shader, and now we get the properties for this object. And for emission color, which is what we're using, it's an underscore emission color is the attribute name for this shader. So underscore emission color, let's use underscore emission color right there. That's going to get that float value, although that's not a float, that is actually a color value, which means that this should also be of type color. Once we have that, the only value I really care about, well, I care about them all. We're going to need to push this color vector, as I'll call it, down to 0 over time. Now, if we look at it right now, what is it? It is red. It has an emission value, and the only component is red. All the other ones are 0. Therefore, I only have to worry about the red component when I'm actually subtracting this out. Within our while loop is where we're going to want to slowly reduce this. First, though, we do need to calculate our increment. So let's do LED increment, which is how much we're going to remove over the period of time that we want this system to fail. And we're going to have the LED die. I'm assuming the LED is hooked up to some sort of a capacitor, which is providing it a continual charge, even though the power has gone out. So let's just continue with the 5 for the fan speed. So LED increment is going to be equal to initial ambient value dot R divided by the unit of time, which is going to be 5. And really, if we're being nice programmers, I should say 5 float time to power down is equal to 5.0 F. Grab that value now and replace these ones here with that. Okay, so now we have the LED increment amount to remove each time we do this loop. So let's go ahead and do that right here. Let's grab that material now, and that's going to be LED light material. So LED light material dot set color, and we're going to set the emission color attribute. And the value is going to be our slowly decreasing initial and ambient value. So we'll do minus equals LED increment, and we'll take this initial ambient value dot R. There we are. We'll take this value and plug it in there. So now this should slowly charge down along with the fan blades as well. Coming back over here, check to make sure there's no problems. Looks like we're all right. Hit the run button, and let's take a look. We can see that bright LED, the fan's slowly dying. If we take a look at the shader, the emission has gone to 0. So perfect. All right, and that's it for coding up and testing the fan inside of Unity now. So that all works with our power management system. Now we can move on to some more interesting things. Thanks for watching. See you next time. Bye.